Hi, I'm Rana Salman Rashid. This is my digital forensics final project. My motivation why I went for cloud project. Cloud is a way to go for everyone. It has something to offer to everyone. If you are a developer, if you are a network administrator, data administrator, so cloud can offer you something. So for this very project, I have my web server, file server, database server, SMTP, everything on the cloud. And for this application, I am not using any SQL or NoSQL databases. Rather, I am using my own files. So one of the benefits is that you don't have to babysit the servers. And then digital forensics, things are changing very fast. Virtualization has brought new challenges to the field. So things are changing. So we already studied different file systems, but now there are new challenges, new file systems. So bad guys can use cloud storage and they can perform their malicious activities from the cloud. So also another benefit is that we can use cloud storage like S3 buckets, AWS S3 buckets as sandbox. So we can run our forensics analysis there. So my application, it has like 3 sub applications, decoupled applications. So they don't depend on each other to run. So they can run on their own. So first is the client application. It's a command line executable application that allows user to perform different cloud interaction operations, like they can create their buckets, they can upload, download documents and files to and from server, they can delete their files on the server. So all the communication between server and client is recorded. And the second application is admin. So this is a simple dashboard, a switchboard where admin can define their malicious activities. It means that they can define their interest. They want this and they don't want this. So by default, I have selected all. So the last but not the least is the AWS CloudWatch. It's a service. It runs on the backend, like it's run behind the scene. So this service uses the power of Lambda function to monitor cloud traffic and will identify, classify, mitigate vulnerabilities by taking appropriate actions. It's scheduled to run every 5 minutes. So on my web server, like one of the bucket I have declared as www, it faces web. So it's a public. So if some malicious activity happens on my web server, so how this service will mitigate? So it will take following steps. So first of all, it will create first it will make sure something malicious has been happened. Once that will be established, then it will create a new web interface directory. It will copy last clean saved web server state files into the directory and then update the access control list, make it public. So it will create a new URL of the new server. Then finally it will send out email to the admin and new URL, and all the malicious activities details will be sent. And above all, steps need to be performed asynchronously. So that was the challenge. So because I cannot send out email before the directory is created, so those things I had to take care. Okay, before jumping into the demo, I want to show some data structures. So this is the data structure log. So I record the client IP, the public IP, like we have routers, and client endpoint within the LAN, the end node. So I will record that address as well. So I will be keeping both addresses. And the next is the big one. This is the file So it has many interesting properties which AWS offers us. So few I will mention. This content MD5. So this is the MD5 hash for the content of the file, not the actual like the file, but for the content of the file. So other than that, it has like, yeah, we can define our own headers. So I have defined one, this proprietary mark. This is my own header. I have, and then is access control count. So for example, one file is associated to one access control list, one owner. But if someone adds that file to another access control list, so that we can compare. So I just give access to one guy, so how another guy is accessing my file. So yeah, so we can do all those things. Okay, so here it's just my is a command line application, so I'm running the list command. So we can upload, download. So any action we do, so the log is maintained on the server. So when file is saved on the server, so this is the like, I have like 3 files, static files on the web server. So this is the metadata, so we can define the metadata. So this one is my own metadata I defined. And then this is like more about metadata. Okay, this is the admin piece. So this is just a dashboard. So there are different options there. So admin can pick and choose. So this is the Lambda function, so we can deploy directly from the Visual Studio.NET. Okay, here we go. So we can jump into the demo. Okay, so I am in the same directory. So let's go. Okay, so it will communicate to the server and comes back. Okay, so it says my account has been locked for maximum unsuccessful password attempts. So I just did on purpose. So I will use another user. So this will be logged on the server that user was blocked, but he still tries to access the application. Okay, it's authenticated. So we can run list command. So it will bring down all the list of all the buckets. So we can see these buckets here as well on the console, AWS console as well. So these buckets are there, and then we can perform some action. So we can do some. We can upload some document. It's a HTML file. I have saved the command to save time. Okay, so this file already exists there. Okay, so the file has been uploaded successfully. So now let's do the attack. So for my own client, if someone uses this client but still wants to do some malicious activity, so he can perform some action, so which could damage the server. So then let's see how our application respond to this situation. So let me show you the console. Okay, so this is the top one. This is the web server right now. So we can go in. So I have these 3 files. So this is the index default page. So if I go there, okay, so I can see this calculator. So this is the project downloaded from the code project. So I just saved I host on my bucket. Okay, so if someone tries to upload a file into the same directory with the same name, so let's see. So So I can change the bucket name here. So this is the name of the bucket. Okay, this file already exists there, yes. Okay, so file has been uploaded. So before that, it uses Windows Defender to see any virus. So there was no virus in the file, so it is uploaded. Okay, so now our web server is on attack. So now let's see. So now the web service, which is supposed to run every 5 minutes. So for this testing purpose, I will run it manually. So now I'm on the Lambda function. So I have deployed here my code. So it's .NET Core 2.0, and I can run. Okay, it's running. So it's a long process. It will first see the logs, compare, and then send out emails. Okay, so it's success. So this is all. I just have the log of everything, and this is basically the HTML. I mean, I was debugging, so it's like I have shown here. So so it has sent out an email. Let's see. So this is the email. Okay, so we have received an email from our AWS web server. Okay, so let's see. So we have everything good with this file, signout.html here. So there are 3 fields have been changed. So the content length have been changed, metadata count have been changed, and e-tag. E-tag is like MD5 hash, which AWS offers. So it means our server is compromised. So as a result, it will say the web server has been compromised, and then it will create a new URL. So it has created the new URL. So we can go to that URL and see. Good, it's up and running. So it's a new URL. It's not the same. So this is this name, right? And then this was the old. So this old have been brought down. So let's see. Press F5. Okay, yes, it is brought down, and the new URL. So we have our application up and running. So we have successfully mitigated the attack. And now let's see who did this. Okay, so we have different. So this was the blocked attempt. So blocked user attempt. So this was not the thing we are looking for. Okay, so this is the different bucket. Okay, this is the bucket which was acting as our web server. So now this is brought down, and new web server has been assigned. And this was the public IP, and this was the endpoint. This is the end node IP, and this was the timestamp, and the action was upload. So we have successfully mitigated. So now I will quickly do another type of attack. So what I'm gonna do is, so if not client, if someone from AWS console changes something, so it should respond as well. So let's see. So this is no more a web server. So this was the old file. This is the old bucket. See, we don't have anything. So if we see, okay, so here we go. No, I think it's not refreshed yet. Let me do Control F5. Yeah, we have a new server. So this is the server. So it has all the files which we need. Okay, now let's change this file. So we can change the metadata on this file. Change metadata. Okay, so here is the metadata. So it's GoCloud PMN-1. So I will change it to changed, and we'll save. Okay, so it is changed. Now let's run our service again. So we'll again manually run this service, and we'll see. So I can just delete this old file. Okay, let's go to Lambda. Okay, let's test. Okay, it's done. So let's see if we have an email. Yes, we have already an email. Yes, see the first file, all other files are good. So we have only issue with this file. So there was no other action. So we have none here. So no action from the client application, but this issue happened from the outside. So see, so we can find, and again a new URL is created. So yeah, so this was the old one which we were using, this one. So if we F5, do F5, so see it's again gone, and we can see this URL. So it should work. Yes, good. So it's working. So we have handled both the attacks, both from the inside and outside. So similarly, any type of attack happens. So we compare a long list of parameters. So we can hopefully mitigate, and we can add to this file. And finally, the future enhancements. I mean, I have something already in my mind. So I'm depending on the Windows Defender for this, for the virus. So what I can do is, if I'm not sure with the client malware protection, so what I can do is, I can create a separate bucket. It will be separate bucket, and it will be like isolated, and then it will serve as a sandbox. So I will first upload into this bucket, and then I can pass URL to the virus total, and we'll see. So if it has any malicious activity, if it has, so I will not copy, and I will error out. And if it is good, then I will copy into my server, and or any other bucket. So this was like I was using my own file system, so I had to handle a lot of situations, lot of conditions. So if I use central data repository, so it will be easy. So next time I might use the central data repository, and like some RDBMS or open source NoSQL database. And then .NET Core Lambda function is .NET Core 2.0, which is like support both in Linux and Windows, and I believe on Mac as well. But my applications console is only for Windows. So I have planned to implement in .NET Core. So this way it will work like cross platforms. Thank you very much, and I appreciate your time, and your comments would be appreciated. So I can just give the quit command. Thank you. Have a nice day. Bye.